So to finish our discussion of support vector machines, I will run through a small example and also show you the interesting side benefit we got by using support vector machines and stochastic gradient descent to do our optimization. So let's think about a new setting, and we will call this setting the online learning case, where the idea is that we want to model problems where we have a continuous stream of data. And we want our algorithm to kind of learn from this stream and slowly adapt to the changes in the data. So imagine we are basically receiving data one after another, and the data is slowly shifting over time, and we would like our model to learn these slow shifts and adapt to them. So the idea we'll be using is to slowly update the model as the data is arriving in. And what we notice here is actually that in our SVM formulation we made so far, whenever a training example came in, we can think of it that we classify it, then we see whether we classified it correctly or not. And if we misclassified it, then we computed the value of the gradient was non-zero, and we would make a step. This was in the formulation of the stochastic gradient descent. So our idea here, we can think of it the following, right? We can think that we first train the classifier on the training data, and then, you know, for every example that comes from the stream, if we misclassify this training example, we update the model using a kind of a very small learning rate, all right? We just want to slightly update the model. So let's consider a small example of how this online learning case would work. So let's think that we are operating a shipping service. And imagine that we operate in a case where customers come to our office and they tell us the package that they would like to ship from some origin to some destination. And what we would like to do is we would like to offer them some price. Let's say we offer them some value for how much the shipping would cost. And then based on this price, sometimes the user or the customer will decide to use our service, and sometimes they will decide not to use it, and they will go somewhere else, right? So this means that kind of every customer, every origin destination point and description of the package is a training example. And then the classification that we want to make is, given the price we suggest, is the user going or the customer going to accept that offer, or are they going not to accept the offer? So X describes the customer, the price, and the package, and Y says whether the customer is going to accept our price or not. So the task now is we want to build an algorithm to optimize what price should we offer to the user. As I mentioned, features X simply capture the information about the user and the origin information about the origin destination. And the problem is, given a price, is the user going to accept it or not? So how would we go attack this problem? We could use lots of historical data where we would say, where we would use our features to be of the type of something about the user, something about the origin, something about the destination, and the price we set. And then Y is simply a +1 if that user or that customer accepted our offer, and -1 if they haven't. And we would want to find the function f that, based on the x's, predicts the y's. We could, for example, use support vector machine. We would train the support vector machine on some data, and then we would go and deploy this model on our, let's say, website or in our store. However, one important thing here to note is that the website is running continuously, and as the website runs, maybe the economy changes over time, which means that at some point in time people are a bit richer and they are willing to pay a bit more, and at sometimes they are maybe willing to pay a bit less as the time goes on. So instead of kind of thinking about training a classifier, building the model, and then freezing it and shipping it off to our website or to our store, here is how we would think of this in an online learning setting, where the idea of the algorithm would be to do something as follows. A user comes to our store. We represent user as a X, Y pair, where X are the features and Y is whether the user choose our service or not. Based on the decision of the user, of the customer, we update our weight vector W using just the customer we saw, and by making small updates to the parameter vector W, we slowly adapt to the changes in our customer base. So what did we do here is basically we discarded the idea of the training set, and instead we think of a continuous stream of data whenever a user comes to our store. If we correctly classified the user, we are okay. If we misclassify the user, we update our model a bit. And when I say correctly classified or not, it means did we suggest a price that the user picked and was happy with, or did we choose the wrong price? Of course, there are some further things we have to think about. Right, the first one is that in a major website that like ours would be, we would have a massive stream of data, and as we are training, as more data comes in, our model gets better and better, which is great. What is also good in this online learning setting is that all we need to do is look at one example at a time, so we don't really need to deal with all the training data at once. So this is another kind of benefit of stochastic gradient descent, where we are only looking at one data point at a time. And if what we can do, for example, if we don't have a lot of data, then we can run stochastic gradient descent while traversing over the same set of data multiple times, right, in multiple rounds until our algorithm would converge. So to summarize, online algorithms can adapt to changing in user preferences. For example, over time, users may become more price sensitive. This means that algorithms can adapt to data and learn these kind of changes. And in this sense, the model becomes dynamic, and also the underlying system is dynamic. And this is kind of the side benefit of the way we trained our support vector machine using stochastic gradient descent, which basically means that whenever a new data point comes in, we classify it, learn the class, and we can slightly update the model. So we can think of this as kind of the system that is always learning and never stops learning.